Okay. Hey, ViteConf, how you doing? All right. It's early morning. Yes. Thanks. Appreciate it. And honestly, like Matt was just talking about AI and how that transforms developers and improves developer experience. And so does modern tooling like Vite. So in a way, can we all just feel blessed for a bit to use this amazing tool and give it a round of applause? Awesome. And the best part here is, like, I talked to so many people yesterday, even today, and there will be so many more. You all have a different background. You use different frameworks. You still are here united. So I just think about your favorite framework out there that you use. Just think of it for a second in your head. And on three, I want to hear which framework it is, okay? 1, 2, 3. Exactly. Yeah, mine too. True. And I hope this is also on here, on this list of frameworks. Anyone feeling left out? No hand. Perfect. Oh, one. Okay, we'll talk in a bit. Okay, we'll talk there. It's fine. Don't say it's plain HTML. That doesn't count. And of course, they all have in common that one thing: the shared infrastructure of the web, Vite, right? But what is under the hood of Vite, and how is it going to change? Well, we'll learn about that more in the talk. Rolldown, how Vite bundles at the speed of Rust here at ViteConf. Reza already did a phenomenal job introducing me. I'm Alex Devil at VoidZero. I'm feeling really grateful being part of Evan's company for 1.5 years now. I already did a little bit of web engineering consultancy, give talks and workshops. I'm part of the Nuxt.js team as well, so you know my favorite framework now. Yeah, but no worries, this won't play a big role in the talk. I also do a bit of YouTube and have a website that I always say I should update, but never do. You all know the pain as well of portfolio pages. We don't have time for that. So the current Vite stack, how does that look like at the moment under the hood? Because Vite itself, it's a great build tool, but it's using certain bundlers under the hood. And we have ES-build, first of all, right? Written in Go for pre-bundling, for transforms, and for minification in production. And then we have a second tool, Rollup, right? One of our favorite bundlers there. We do the bundling in production, has a phenomenal plugin system and API, and it can also do a bit of chunking here and there. And any React users here? Can I quickly see some hands? Okay, like a third of the people. All right, good. You might use SWC as well, right? For React Fast Refresh, or also for alternative transforms. And while Rollup is written in JavaScript, we have ES-build in Go. SWC is written in Rust. So far, so good. But in a way, this feels like a lot of tools under the hood of a single build tool, right? So at some point, the question was, why not unifying these underlying bundlers? Why not making one thing out of it? So we'll take this and we'll just go to Rolldown Vite, right? But I know you start like, why another bundler? Like, do we need this standard XKCD? Like, oh, we don't like all the standards. We just have a new one. Then we have instead of 20 with 21. Great. Don't worry. It's not like that. I promise. But first of all, what is a bundler even? Why do we even need a bundler nowadays, right? And this is a bit like, you might all know that, right? Like, of course we have a build step, fine. But there are a lot of people saying we don't need that, maybe. So we have a look at this here, right? Anyone has an idea what it is? Just say it. Lifecycle, interesting. No, it's a module graph. Like we see here, TSX file pointing to other files. We have like some dependencies using React, using Bootstrap, right? Good old times. Here. And we build applications like that, depend on files. We have maybe circular dependencies. I hope not. And eventually our bundle will transform it in this. Anyone knows what this is? Yeah, exactly. Analyzer, it's close. It's a tree map chart. Weird name, I admit. But yeah, exactly. Here we see actually all the modules that are coming out. Here we see Shiki here, for example. These are actually the slides you're seeing right now as a bundle, because this is just a simple SPA. So it's kind of a full circle. And yeah, this is what the bundler produces eventually. But why? Why do we need this afterwards, right? I mean, luckily, our users don't see that. They actually see the application. Well, we had that moment at the Railsword a couple years ago, right? No build. I must say, build. Build. So why is that? Well, actually, this. Hello ViteConf, a very simple JSX component, right? Can be used in multiple frameworks, React, Preact, etc., even in Vue. And this is, the browser doesn't know what that is, right? So we have to somehow move this into JavaScript. Somehow we have to transform it over. Same for other formats, like using a file component, for example, and also this. What is this? TypeScript. Yes, actually wrong TypeScript, because one is not a number. In this case, it's a string. So there's a little squiggle here. And also this, yeah, sure, we can just remove the types and we're good if you use erasable syntax. And then we also use dependencies, right? I mean, probably none of you is like, I just built everything myself and reinvent the wheel everywhere. We don't do this. So if you use a dependency like date functions, because temporals aren't out yet, we still have the pain point of dates in JavaScript, right? Months start at 0. Yes. We want to, for example, format dates. And then we want to make sure, okay, there are a lot of functions in this date functions library. We don't want to get them all, right? So we need tree shaking. We want to make sure code ends up in a bundle that we actually use and not all the unused stuff. And then also we want to have this, right? Any idea what this is? Yeah, exactly. This is the minified code from just there, actually. So we just take that, and luckily you don't have to read it. The browser will interpret that, and we're good. This is just a minified version. We even see some constants here, right? Like how many days in a week and days in a year, etc., etc. So to a production-grade application, we also want to have small JavaScript, ideally also runtime optimized, but also small bundle size. So there are a couple of reasons why we actually want to do that. So we want to transform the code, as mentioned. We want to remove unused code from dependencies. We don't want to use that. We also want to make sure the code is split up in a clever way, so we don't load unused JavaScript. If we need it only on one page, why load it at the start? So we do it on demand, which means less network requests and reduction of waterfalls, obviously. And eventually, minification. So yeah, this is kind of the job of a bundler, and there are some underlying tools for that. We're going down the ladder in a little bit. But now we answer what a bundler is, why another bundler. And of course, Rolldown is written in Rust. And you might wonder, okay, why? But before we come to that, why exactly for Vite? Why do we need to unify all the things? Well, of course, it is increased complexity for all the people maintaining Vite. Maybe you as a user to some degree, if you write your own plugins, possibly, but still. Increased complexity, this is not necessary in a certain way, but also we get inconsistencies between dev and prod. With a bundler, this is at least a bit reduced. Still, Vite's dev server is unbundled at the moment, so there will still be some inconsistencies, but it will be better. And of course, there are also limitations for the tools used under the hood. So limitations where the rollout team or also Evan from ESBuild says, out of scope, I don't want to do it. And that's perfectly fine. We all have to say no, right, at some point. But there might be important things for Vite or other scenarios. And of course, our production builds can be way faster. Who thinks their production build is fast? 1, 2, okay, 3 people. Okay, you're using Rolldown already? No. Federation, okay, all right, fair. We'll get to that in a bit. We'll get to that. There's a talk about that, right? So yeah, 3 people saying it's fast. The other people might be like, okay, it could be faster. Let's do that. And when it comes to Rust-based things, we always have this meme. Rewrite everything in Rust. This is the 10x developer guide. I tell you, it's time for a change. No, of course not. Of course not. And it's important. If we talk about Rolldown, Rolldown is not just a Rustified rollup port. Initially, the idea was like, okay, we can take rollup, we might be like, can just Rustify, but this doesn't do the thing. This is not enough. We actually had to go a step further because it's not just like, okay, there's a thing that's there, let's just port it over, it's magically 10x, 16x, 25x faster. Sadly, it's not reality. Actually, we have to look a bit outside this, like, okay, this is the thing we're using, box. So why not take a look at all the prior art and take the best parts of it? It's more work, but it's really worth it. See what other projects did very well and, well, be inspired by that. And of course, one big thing for the Vite ecosystem is Rollup's plugin API. So Rolldown is, of course, compatible. So you can use your Rollup plugins that you already use in Rolldown. So JavaScript plugins, no problem at all, compatible. It's also important because it's not like, hey, Rolldown is not a default bundler at some point. You have to change your application fully. That would be a tricky experience, so to say. The other thing is ESBuild, super fast, right? It's written in Go. It also has some very nice behavior like inject, define, etc. So also there, why not take that over? And last but not least, yes, you see it right, Webpack. Anyone still using Webpack here? A couple people, all right, kudos. Okay, I see. But Webpack was an amazing tool back in time, and it does still things amazingly well, which is optimization, which is chunking. But I don't want to go ahead. Jakob has a great talk on that after the coffee break about Rolldown's chunking. So I'll just give you a little foreshadowing here. That's definitely a feature that's very important because neither ESBuild nor Rollup can do that in an extremely well manner, but Webpack could. And of course, there are also, as you said, features beyond that. Built-in HMR in Rolldown, import map generation, CSS bundling, work in progress is coming, and also first-class module federation. So people using federation will be very happy for that in the future. So that's in the plan there. And also, as we mentioned, well, we need minification and also a transformer to like do all the things through OXC. And now we go down the abstraction level one more. But before that, we said TypeScript, right? TypeScript support would be really nice. Why not having that directly integrated in Rolldown? So we have built-in tsconfig support to say, hey, just point to a tsconfig, and we will respect the paths that are defined there and compiler options paths. We also make sure that the tsconfig options, so like the target, they are merged with the transform options, and you don't have to define it everywhere once. That's pretty helpful. Module types in Rolldown is another feature that's pretty interesting because as a bundler, we've seen it before, we have different asset types. We have TypeScript, sure, we have JSON, we have assets like images, like files. So we want to deal with them. But on the other hand, if we have a new framework, that would be nice to somehow deal with that as well. Let's say, okay, we think of JSON, we think of assets, JSX, TSX. Let's think of them in classes as module types. So let's say here we're creating a new framework, let's call it Swangular, right? And we say, okay, in module types, we define, by default, they're of course set based on the file ending and extension, but we say .swangular is now handled as JSX. We can just say that straight from our config, and it's fine. We can write .swangular files, and they're handled as JSX. So I want to see that on GitHub tomorrow, please. Also, we can do the same, but through a plugin. So we can say, okay, I want to do something with my Swangular files, right? So if the name ends with that extension, great, I want to transform some code, like I want to load it differently, and I set the module type to JSX. In that way, we can also say certain files with different endings, just handle them straight away as CSS, as JavaScript, after doing things with them. So this is pretty helpful to make sure that your assets are handled correctly. And that's also built into Rolldown itself. Great. Another thing about plugins are hook filters. So we just seen actually a Rolldown and a Rollup plugin. They work together because they're all compatible, right? So if we see that pattern here, we have this, for example, if ID does not end with Swangular, or the other way around, if ID ends with Swangular, then do something, or if you don't do anything, early return. Boom. Common thing in Rollup plugins. And the problem with this is, if we do it together with Rolldown, well, this plugin function has to be executed again and again in the JavaScript land. So Rust says, okay, executed plugin, it's executed, and back and forth for all your dependencies, because it doesn't know that it's only relevant for .swangular files. How can we change that? We can make sure that this is actually graspable for the Rust side. So instead, we transform that code, not related to the hook though, we change it over to say, okay, we have a filter here. And then we say, okay, the ID should include .swangular, and that's at the very end. And for that, execute your handler function. This is something that Rust can easily understand. We can bind it, send it over to Rust side, and then it can be evaluated. The regex will be parsed, and then only .swangular files will be considered, and the handle will run there. The great thing with this is, obviously, way less overhead between Rust and JavaScript, so performance boost. You don't lose anything in terms of bundle size by that. It's more like your build performance will do better. So you don't have to execute your hooks in Rollup plugins again and again. That works, by the way, in Rolldown, in Vite already, and in Rollup too. So there's no reason not to use that already if you use a plugin, because at some point it will benefit you. And the fun fact here is, if you rely on a plugin that might not be that well maintained, can happen, right? You can even apply that yourself in your config. You can have a with filter function and then apply the same thing to even optimize your builds. If you say, okay, this .swangular plugin, I know there's like a query parameter, I only want to apply this for this file, you can do that. So even there, fine-tuning is possible. And that's pretty important to reduce, as I mentioned, the Rust and JavaScript overhead. Oh boy, we had a long discussion yesterday at the pre-meetup about ESM only. Anyone switched to like full ESM only dependencies here? If they maintain any packages, a couple people, nice. Yeah, you are moving the ecosystem forward. Like, big shout out to all the people moving to ESM. Hell yeah, nice. And I have to announce today that You can generate ESM, CJS, and also other output files with Rolldown. That's fine, but you don't need to. But Rolldown itself ships as ESM-only package now, for a while, actually. That means you still can do CJS if you want to, ESM, etc. That doesn't change because there's still some reason, like VS Code extension, some plugins for simple system, etc., etc. But Rolldown itself ships as ESM, which is great. Awesome. A little screenshot from the node modules inspector made by Anfu here. And also the usual encouragement, use ESM if you can. Okay, and it doesn't stop there with all these features. We had new features in the bundler. We want to change things, but we go, as I said before, one level lower. Because to build a bundler, you actually need quite some tools, some kind of foundation. And here comes in OXC, the JavaScript oxidation compiler. If you take a close look at the logo itself, here you see an anchor, right? The anchor is Rusty. And how's Rust being created? Oxidation, yes, correct. So we have the water and the background oxidation. So the JavaScript oxidation compiler. Rust wordplays are insane. And Rust, so OXC as a collection of Rust tools, so as the JavaScript oxidation compiler has a couple of them. For Rolldown, important is transformer, because what we want to do is non-JavaScript code such as TypeScript, JSX over to ESNext to transform that. That's happening through OXC transform. You can use all of these parts separately, and there will be also more talks about OXC later. So also there, don't want to spoil the fun yet. The transform itself is built in React Refresh, and syntax lowering is of course possible. So you can just say, okay, I want to go all the way back to ES 2015 if I have to. Interestingly, you can also create your DTS files, of course, way faster using TSC when you enable isolated declarations, because then we can skip the whole type checking step there easily. It doesn't do type checking then. And actually, a pretty cool feature is that the OXC transformer has built-in support for style components. That's also usually a common thing in React applications, slowing down the build process. So there's a plugin for that. And you can use it instead of the existing solutions and get faster builds. Well, who doesn't like that? And actually, it's the fastest transformer. If you have the slides later, there's always a link. So it's very important to give benchmarks that are open source that have the chance to be reproduced. So take a look. I made a little chart here, first of all, for emitting DTS. As mentioned, it doesn't do type checking, so it's not 100% apples to apples, right? But you see the speed up here. And yeah, OXC is this little blue thingy there. And also, transforming and lowering is a big difference to SWC and to Babel. And then we have the minifier. We talked about this production-grade application, right? So I want to minify. And now I could say, like, look, oh yeah, we have the fastest minifier. Not true. We don't have the fastest minifier. We're pretty honest there. Then it must be the minifier with the smallest files at the end, right? No. I have to disappoint you. It's not the one with the best compression. Why? Well, you can only optimize for one in a certain way. If you go for the fastest, then you rarely have the best compression. If you go for best compression, it will take a while. So instead, we said, hey, why not have a good trade-off? One of the best compression speed trade-offs there. There's a lovely benchmark made by Private Number. So let me quickly open this here. There are a couple of files benchmarked. Minify benchmarks are really difficult. If we take a look at Cursor, for example, here, okay, original size 1.01 megabyte, gzipped, like without minification, of course, both 139.76 kilobyte, and then minzipped and minified, OXC minify here taking the lead, 122.02 kilobytes compared to SWC, has like a kilobyte more, but it runs 5 times faster than SWC. Now, as mentioned, there are different files where also SWC is in the lead here and there. It really depends on what you actually do. But the most important takeaway is this isn't like a magnitude different. This is all pretty close, but at least you get 4 to 5 times the speed, which is, well, sometimes even more important. So feel free to take a look at the benchmark. Also there, links on GitHub, it's all open source. And it's great, but complicated. So let's take a look at that from the top level. You have your framework, right? You already said your favorite framework. That's perfect. Love your choice, by the way. So we have your application code, your UI, your logic. Then you have Vite, that's like the build tool, the dev server, plugin system, etc. And Rolldown, of course. It's bundler, that code elimination, cross chunks, tree shaking, and chunking. And Rolldown itself relies on OXC as parser, resolver, transformer, minifier, and Lichter informator, but we'll get to that later on today. So let's have another closer look at Vite again. To be precise, at Rolldown Vite, because Rolldown will become the default bundler at Vite 8. And in Rolldown Vite, because that already exists, we have native plugins. So we said, okay, let's Rustify a part of the Vite internals with the help of, for example, OXC and Rolldown. So aliasing, resolving, JSON handling, etc., is fully Rustified. Why these plugins? Well, because they gave the greatest gains, and that was a good trade-off in the end in terms of performance. And of course, there are more coming in the future. Now, these, if you use Rolldown Vite, they are enabled by default already. The next ones will once again have an experimental flag to use. Then you can, instead of like true or v1, you can say enable native plugins v2, and you're good to go. But that's for the future there. And this gives a big part of the speed. But now you might wonder, okay, we can talk about performance today. Can you show us some real-world impact? Is there an actual thing? And the answer is yes. There are like up to 22.3 times build time reductions, not percent, it's really times, for production builds with Rolldown Vite. There are reduced memory requirements when building, so we see people reporting different numbers there. And it can even lead to smaller bundles. So in some scenarios, you even get everything, faster builds and smaller bundles. It's amazing. Fun fact, as I'm working in the Nux team, I was like working on Rolldown Vite PR right there to support it, which already works. And you know, we have this size test. So like, okay, size is failing. And I want to have a look, and I was like, okay, how bad is it? And the answer is, it's actually better from 113K to 111K. So that's pretty decent. This is one of the CI files where like, I'm really happy for that. That's amazing. And this is for a minimal application while building faster, which means with your code, that will be even less. And I said, okay, look, this is one specific framework. We can't say that. There is a repository called Rolldown Vite perfwins. And in there, people with open source repositories, with private repositories, they reported the numbers in terms of how the build time changed, for example, from plain Vite over to Rolldown Vite with, for example, no native plugins back then when they were not enabled, to native v1, which is the current state. And at the very beginning top, we have outline, right? There's a PR. This is an open source project going from 47.27 seconds all the way to 2.12 seconds, so 22.3. We see 17, 16x, also Excalibur, one of the very famous applications in there. And feel free to have a look and also submit your own stats there. It's always nice to have them. Of course, not everybody will like get 16x gains. It depends on what you use as well. For example, if you use the React compiler, as there is, well, it's a Babel plugin, so that will take a good chunk of your build time and other things. But if you hit any issues, well, feel free to send over a message on socials, on our Discord, or, well, slide my DMs. But even there, now we talked a lot about build time, and we talked a bit of bundle size. I've plotted a little chart of the Rolldown Vite versions, so Vite with Rolldown, from the version 6.3.17, so 25-ish versions ago. And it's the same project, a minimal React router application. And we just take a look at the bundle size. In the beginning, it was, okay, we have some anomalies here. It was quite high here and there. It went lower, a bit higher, and lower again, and consistently lower and lower. And if you see here, we're at 42.25 kilobyte roughly. And back in the beginning, we're like at 43. So even the most minimal application there, just like importing React router and logging it, gets improvements throughout the time, which is pretty amazing. You get these gains by doing nothing except upgrading and updating versions. So once again, what that means for your own code, you have to try it yourself. Now let's talk about the future plans of Rolldown Vite a little bit. In the current phase, we have a separate package, right? We can test it, stabilize it, reporting bugs, always appreciated. And in phase 2, well, there will be a beta for Vite 8. So instead of the package, we just say, hey, Vite 8, beta 1, 2, 3, etc. And eventually, well, changes are merged. We get Vite 8 and Rolldown as the default bundler. But until then, are you ready to use it? Well, you can, as mentioned. Switching is pretty easy. It's not difficult at all. You have your dependency list there. You say Vite, and you just give it an alias, and you're done. If you use a framework that uses Vite under the hood, you can also just use a PNPM override or similar, but it's not that hard. So feel free to give it a try. Anyone tried it out here already? Just take a look. Okay, yeah, pretty good. Okay, all right, nice. Let me know your experiences around the day. So the best part is no app code is required to change. You might have to adapt your Vite config a little bit if you use ES build options, etc. But in general, that's the way to go. And then you might want to optimize even more. But that all depends on the application. And of course, that's not the end yet. We want to unify the whole tool chain, but that's for tomorrow, guys. Thanks a lot to my sponsors here, and thanks you for your attention. Thanks, everybody.